tutorial. So we try to learn the Civil 3D practical uses as we have provided a playlist. You need to go through our previous video because this is the series of videos. So you cannot miss one video and to learn complete a Civil 3D if you are a beginner. If you know Civil 3D, so you can use this tutorial for your only assembly and cross sections. Actually, Civil 3D we use assembly to draw a cross section, and cross section is I will demonstrate you that any channel have its cross section, a specific a particular section with a constant slopes, with a constant bed widths, whatever the design, it depend on the design. So channel have its own cross sections, tunnels have its own cross section, roads have its own cross section. Roads normally we have right lane and left lane. In this tutorial we will cover respect to the road. So if you understand about roads, you can draw the cross section of the channels. So let's go in Civil 3D, and this is assembly. From assembly you need to go to home, assembly, and click assembly. When assembly is here, I call it cross section because this is basically a cross section 1. There are assembly style, basic, assembly set style, code set style, vivid it, okay. You need to click here. If you click here, this icon will appear. This red icon with yellow rectangle will appear with inscribed circle. Okay. Now you need to click on your tool palettes here where we have to R control 3. If control 3, this will appear like here. This appear. Now I click here, it will appear. Tool palettes, several sub-assemblies. We have the tool palettes, basic lane transition, generic pavement. All these shapes are available. So if you need to some additional and typical cross section, you need to go to the sub-assembly composer. It's also one affiliated app with Civil 3D. Okay, we have the tutorial on the sub-assembly composer. You can check in the playlist. If you like the video, next video will be in this playlist will be appear for your information. We have the assemblies here already, basic assemblies, lanes, shoulders. We have different, curves, daylight, generic, rehabs, bridges, all predefined or pre-available sub-assemblies. So I will use this basic lane for today's my tutorial. So I just click basic lane here. So I just click on this part. I will again click on this line. If I click this line, both right and left lanes are available with negative 2% slope downward. Negative 2% slope downward. So escape it and select it. If you select it, you have two options: sub-assembly properties, assembly properties. If you click here sub-assembly properties, it means you are dealing with the right only. If you clicking assembly properties, you are dealing both. So first let me click on the both because I have concern about the both. So you can change your sub-assembly name here, description here, properties here. So I just go to the construction. I will click here. So you need to drop down this one little bit or increase the size of dialog box and take a dialog box aside. Here we have the side is right. Okay, So I will change it into 3, and the depth is here 0.2. It's up to you. What's your structure of road structure depth? Then -2, it's okay with me, so I just click apply. If I click apply, you can check here is the offset automatically become 3. Just click into the left baseline, and then you need to click it also 3, because normally road have right and left lanes are same. So just I click here apply. So both sides now become equal. Others parameter inputs I will not change. It depends on your road structure and your road sizes, available road sizes. Because Civil 3D is basic solely for the geometric design. So you need to consider your geometric design, earthwork, and okay, just click OK. When you click OK, your sub-assembly, your assembly is ready. Right and left lane is ready. So then you have to provide the slopes here. Slopes here both sides. So as early I have told you that if you have a sub-assembly composer, you can design your own custom slopes. If you don't have, so you can go, normally I will use here from my this available predefined tools, I will go daylight. Daylight, we have different slopes here. Daylight side RW, you can click here. Daylight offset, daylight width, daylight. Just click here and just click here. Let me first do this one as a sub-assembly. Just click here, daylight bench. I will choose daylight bench here. You can choose your own on your need base. After clicking this one, I will go a sub-assembly properties. Then I will check here. You can see the cut slope is 2 1. 2 ones mean 2 horizontal, 1 vertical. So I will keep 0.5 ratio vertical. Maximum cut height I will keep as 3. Fill slope I will keep as it is. Maximum fill slope I will keep as it is. Benching I will convert into 3. Benching slope I will convert into 0. So just I will apply. Okay. Now my bench slope and condition are predefined and already set it. Now I will choose this one and I will mirror this one, this daylight slopes on the left side. So I just go and mirror it. Okay, so if I will mirror it, it means it will mirror from here. I will control Z with go control Z and select again, and I will mirror it from this point. Okay, so now my both ends are completed, because this also provide me the daylight will follow up to the ground level or up to the earth. If the earth is below this road level or this point, this profile will be above the natural surface level, the daylight will follow downward. If the natural surface is upward, the daylight will follow upward. So this is is completed for our cross section. In next video we will cover the corridor, and we will learn about corridor. So let's come to the corridor. Corridor is basically the combination of cross section, profile, alignment. It is basically a combination of all these three. Without all of three components, you cannot prepare a corridor. So let's go to the corridor. Home, we have corridor here. I will click here the corridor, and corridor I will call it corridor 1. You can call it a specific name for yours. Alignment 1, because actually we have one alignment in our project, so I will have one alignment. Design profile, we have one. Surface A, no, design profile A. Then assembly, we have cross section, only one cross section. You may have multiple cross section. Target surface, we have surface A. You maybe have multiple target surface, you need to choose one. Okay, you need to apply this one. Now you can see that your corridor is ready. This is corridor. Actually alignment, we have previously only one this center line. Now we have the side slopes, and we have both our right and left widths. So width, lengths actually from the beginning point. So you can select here, and now you can check from your object viewer. You are ready with this one. You go to the isometric and increase the size. You can see that this is the daylight, and I will change into conceptual. Realistic is I think better. Yes, realistic. So you can see that this is our road center line, and this is right and left width, and this is the daylight, fill daylight here, because our profile is above the ground level. And here is, you can see that there is some cut here in this right side. So here our profile is below the natural surface. So let's check the profile here. Normally you can see that our profile is below here in this portion, and our profile is above in this portion. So this portion daylight will be the fill, and in this portion the daylight will follow the cut. So this is our corridor. So in next video we will learn about corridors properties, corridor surface, how we will take off the quantity of any road projects or any